There we go. Okay, let's see. Before we get into new stuff for today, reminder, there's a project due this weekend on the web scraping. Anybody have any questions about that? No? Overall, the project itself, the material, I think is quite a bit harder than the previous ones, but because there's that video that goes through most of the hard parts, students in the past have found this project to be on the easier side, even though the project itself is relatively harder. But there's still a lot of weird edge case things that can come up, so I definitely recommend not putting it off until Sunday night. It's due Sunday night. And again, if for whatever reason you don't get it finished by Sunday night, the late penalty in this class is if you wait till Monday and say come to office hours on Monday and ask me a question, then it's only a -1 out of the 16 points that is the assignment is worth. And so it's a very minor penalty. But if you, for whatever reason, submit something that is not correct, you will probably lose more points than if you were to submit something late that is fully correct. Okay, we also have a lab tomorrow. The lab, I've posted it now in this topic 9 syntactic sugars. This is the folder that we've been in this week. And it's this lab war dialing. The due date for this lab, so again, my hope is that at least vast majority of the contents of this lab you'll be able to complete during the lab time. This particular lab will require you to have a program that runs for about an hour or two to collect some data. So you definitely won't be able to finish the entirety of the lab during the lab time because the lab time is just not that long. But you should be able to hopefully complete most of it during the lab time. But because there is the other assignment due this weekend, I've extended the due date for this lab to be next Tuesday so that if you don't have to be struggling to finish 2 assignments on the same day. I do feel bad. We've had a couple of times where this is having this conflict about the labs and homeworks due at similar times. But trying to push things forward just a little bit because the semester is coming to a close here, and I want to make sure that the end of the semester is relatively relaxed in this class. So I guess busy-ish week this week, so that future weeks are on the less busy side. But again, this is the lab for tomorrow, and the main announcement thing here is the due date on Tuesday. Speaking of homeworks and grades and projects, things that you have to do, one thing that we haven't talked about in a long time is this caveat task for this course. Nobody's completed it yet. The caveat task here is, again, so the way your grades in the course determined standard grading scale, with the exception of this caveat task here, that if you are hoping to get either an A or an A- in this course, you must complete this caveat task. Without completing it, the best, all grades will get reduced by 1 letter grade. So for example, an A- would become a B-. And the caveat task here, super easy. You just have to either watch some videos or read some stuff and post an issue to GitHub issues here. There's a link right down here on where to post it. Shouldn't take you too much time, should be relatively relaxing and enjoyable, but just make sure you don't push it off to the end of semester and forget about it, because then I will have to dock you a grade and I don't want to have to do that. These videos and readings are all about the hacking philosophy, or things that I think all computer scientists, anybody who has done anything related to computers, should know about. So that is why we have that caveat task. But they're not technical, so it should be easy, just like watch it before going to bed or something. Any questions about anything administrative before we move on to today's technical material?
How many projects do you have total?
Good question. So there's 6 projects total. You've submitted 3 of them already this this one right here is number 4, so there are 2 left. You as a senior for the last project will have to do a truncated version compared to everybody else. Yeah. But so 2 projects left and still 1 lab per week left. Other than this week's lab, which is sort of unrelated to the project here, all of your future labs will somehow be like portions of the project that you're working on and more integrated. Good question. Any other questions? Okay. So we're going over LLMs today, using LLMs from within Python. And again, LLMs stands for large language models. It's what computer scientists normally refer to, or it's how the language that computer scientists normally use when they're talking about things that other people normally call AI. So I would not call ChatGPT an AI system, for example. I would call it a large language model system. And the basic idea of what we're going to be doing is seeing how to use APIs to call these LLM type systems. And it's really easy to do. So we'll be able to do a lot of cool state-of-the-art things that, say, 6 months ago, nobody in the world was able to do, but now you all are able to do just by using these APIs. Some concrete learning objectives for us here. So understanding increase LLMs, using LLMs from within Python. We're going to see 2 common security mistakes that people use with LLMs that result in people hacking their LLM systems, or if you are so inclined, how you could hack other people's LLM systems, called leaking the keys and prompt injection. So we'll be talking about that, probably not at all today, but next week. And then lots of practice here using real-world documentation to do stuff. The format of what we're going to be doing today is all live coding of me doing stuff up here. And we'll be writing a simple program to summarize an input document. My recommended way to participate in class is to be following along in VS Code with everything that I'm doing, because you'll have to submit a finished project up to Sakai that will be from our class notes, where I've done like 90% of it, and the last 10% will be just easy submission related stuff that you'll have to do. So follow along with the class notes, follow along with what we're doing today, and definitely ask lots of questions as they come up. Last time I asked you to create the account on grok.com, and so we're going to be using that website here in just a second to do something called creating an API key to use within Python. So yeah, hopefully have this account on grok.com. If you don't have it, then quickly create one and get logged in on grok.com. I also have, so this screen set up, I have VS Code opened up into a new project a new folder I call docsum for document summary. And this is where I'll be putting all of the Python code that I will be writing. And so the first thing that we're going to do in order to be able to use Grok, this interface, is getting one of these API keys. If you click on this link right here, grok.com, it'll take you to an interface or website that looks something like this. And we want to go to actually console.grok.com. So this website that I have right here, console.grok.com. When you press the login button, wherever the login button is over here, after you log in, this is the website that it'll take you to, this console right here. And in this console, it gives you an interface to typing information into the LLMs. It's a little bit more complicated maybe than one you've seen before on like OpenAI's or ChatGPT's website. We're not really going to use this interface at all, but this is the login screen once you are logged in. And the way the login system works on all of these AI companies' web pages is that they send you an email after you try to log in, and you click a link from the email and it takes you to a web page like this. Any questions where I'm at, where we're going, what we're doing? I will try to go pace myself so that we're going not too fast, not too slow, but definitely flag me down if I'm going too fast, and I will slowly make myself go faster and faster in order to try to find the right pace for us here. So from this login page, in order to create an API key, what an API key is it's like a password for interacting in Python with one of these systems. You just click this API keys up here, and I already have 2 of them created, you can see right here. And I click this button right here to create a 3rd of these. This display name for the API key, it doesn't matter what you type in. You can just type CS40 or something like that. What's going to happen is that'll just be the name that appears over here. And it's never going to come up again. So you can, doesn't matter what you type in right here. I'll just CS40 right here. Let Cloudflare do its thing right there. Click the button that I am a human, not a bot, and then submit right here. And after you do that, you get this big, long, randomly generated password. This is like both a username and password combined together, an API key. And what we want to do is we want to copy that, and we're going to save it into a special location in our project folder in VS Code. So now that I've copied this, I'm going to come over to VS Code, and over here I'm going to create a new file. It'll be called .env. So a period, and then env, all lowercase. Oops, what's going on? Do it over here. Right click, new file, .env like this, just a period, and then env, no spaces, no uppercase. And then over here, grok underscore API underscore key equals, paste that big long random string that I just generated. Question is, how did I get this file over here? Just right clicking, new file, and then type in .env. env stands for environment, and you probably haven't, or you might not have seen a file that just starts with a dot before. A file that starts with a dot in a Unix system, so Macs are an example of a Unix system, and basically the entire internet runs on different types of Unix systems. My computer is one example of a Unix system called Linux. In Unix systems, so Linux or Mac, files that start with a dot are traditionally hidden files that the user is not expected to see directly. And so these environment variables, this grok API key right here is called an environment variable. And this is something that once you set it up, you never have to think about it again. And so it's traditional to put it in this .env file. Again, the formatting of this file, it's important that this is spelled correctly and that it's all uppercase and that there are no spaces around this equals sign. If you have spaces anywhere, that will break it. And no spaces at the end of this file anywhere either. That is what it should look like. I'll save that. Any other questions so far? Yes, Lizzie.
I forgot how you get it into like a full new workspace. Like I just have a new folder, but I don't know if that's
just inside of a new folder should be fine. After you create that folder, though, if you click File and then Open Folder right here and open that new folder that you've created, then it'll be just like zoomed into that one spot. Okay, so this is everything that we're going to need this web page for. And coming back over to here, under this project setup, we've now done this line, and this line, all 3 of the project setup parts. Maybe one last thing that I'll highlight is that, so grok here spelled with a Q is different than grok with a K. Grok with a Q, this company's existed for like 15 years. They're a hardware company. They compete with NVIDIA selling hardware. Grok with a K is a new company founded by Elon Musk like a year ago, coming out of Twitter. And they compete with OpenAI, generating the actual AI systems, LLM systems. But this is a hardware company, and they offer free access to their systems, so just to advertise how good their hardware is. The particular feature of grok is that it's super fast, and it's about between 10 and 100 times faster than OpenAI. So this is the system that I use for pretty much everything that I do, both because it's free and I think it's better than than the competitors because of its speed. Okay. So back over here, get a basic example working. We're going to be looking at a lot of documentation over the next week or so with these different libraries. And again, one of the goals of this section of the class is not just to get you to do something cool with LLMs, but also so that you can, after you leave this class, do cool things by yourself, being comfortable with navigating these other like documentation that's made for working professional programmers. The goal is to get you comfortable navigating that. And so the first documentation that we're going to look at is this link right here, github.com/grok/grok-python. And I have that opened up already right here. And so you'll notice, first of all, they're using GitHub, like real world professional programmers use GitHub. Nobody uses Sakai, but everybody uses GitHub. And so that's why all of our submissions are through GitHub as much as possible. And lots of documentation down here. The first thing that we'll do is this installation step. And notice that their installation step looks very much like the installation steps that I've been asking you to do for other libraries, this pip install grok. And so whatever you had to do to get those other libraries installed, that is what you have to do with this command right here to get grok installed. For me, on my system, the only thing that I had to do is get the terminal open and type in that same command. In order to get the terminal opened, I'll just create a quick docsum.py file right here. We're going to be creating a Python file here in a little bit, and press that triangle button, and this will get this terminal window open for me. And now if I type pip3 install grok, that grok, like this, and hit enter, then it is installed and I will have access to that library. But again, for your system, well, again, this is what everybody will tell you to do, but your system, it might be slightly different what you have to type in to get that library installed. And then the next thing that we're going to take a look at is this usage section down here. Anytime, well, yeah, so again, our goal here, what we're building up to is building a program that can summarize documents. It can take a document as input. It will read through this document and provide an output to us about what that document is about. And anytime I'm starting a project like this, I don't start right away thinking about that goal in mind. I think about like something more basic than that, like just how do I actually use this grok system and get some basic examples working before I start actually doing my final goal here. So that's what we're doing in this step one here, is just getting these basic examples to work. And so this find basic examples here again is, we're now at this usage section of the GitHub documentation. And I'm just going to copy and paste this entire thing right here, copy all of that into my docsum.py file like this. And if you try running this right now, you will probably get an error message, because at this point, our code here is not linked with this .env file that we've created. Our code over here is not linked with that .env file, and we have to do a little bit more work in order to get this going. The first way that I'm going to do that is an easy way, but we'll see that it turns out to be incorrect here in a little bit. So the easy way is, maybe instead of doing that, I'll just modify exactly what they have. So this API key, this like password, is what we have to, the password that we created up here, we have to get that into Python somehow. And the easy way to do that is just to copy and paste it. So we'll start by just copying and pasting it, see if I can get something working. And so we have this whole big long string up here. Control C, copy that, come back to docsum, and paste that right here inside of the quotation marks right here. And so now we have access to, or hopefully our Python code will be able to pass this API key over to the grok system, and everything else should work down here. We see there's this like role user. I don't really know what that means yet, but that's okay. And this content over here explain the importance of low latency LLMs. and then it prints out something down here. And so hopefully when I run this, things will work and I won't get an error message. I'll run that, press the triangle button, and we do get a bunch of stuff printed out down here. And it looks like it is in fact somehow talking about these low latency large language models right here. And if I change this content to something else, like how is hacking related to programming, and press the triangle button, then it should start talking about hacking down here and programming and so forth. And so now, in some sense, this is everything there is to know about LLMs, because we now have access to the LLM, and everything else that we're going to be doing in this class is just, in the next week or two, is just Python tricks of getting cool information into these LLMs to be able to ask them interesting questions, and then Python tricks to extract information out of their responses. Any questions about what's going on so far? Did everybody get this working, able to run and get output from the systems? Okay, so this API key up here, let's talk a little bit more about this. I said before that this is not the best way to put the API key into a project, and why is that the case? The answer is because in order to submit this assignment, you all are going to be uploading this to GitHub as a public repository that everybody in the world has access to. And that means your API key, your password, is going to be uploaded to the world. And anybody who looks at your GitHub repo, which I will look at it, but other people might as well, will be able to just read right here what your API key is and use that for their own potentially nefarious purposes. In this case, this API key is not linked to like your bank account in any way, but there's been many famous hacks where somebody has just uploaded something to GitHub, one of these API keys. A hacker just found that API key and they were able to take over the company. So this mistake number one that I have linked down here on the stupid mistakes programmers make with LLMs. The first mistake is leaking these API keys. And it turns out that there are a lot of tools, just publicly available tools for crawling GitHub and stealing API keys from repositories that are up on GitHub. And when you upload something to GitHub, these tools by random people in the world who nobody knows who they are will automatically get run, and every project that you all, even as like non-famous programmers, will have all of your projects scanned for these API keys. OpenAI is one of the companies who's regularly scanning these projects, and if they ever discover, similarly with Grok is one of these companies, if any of these companies discover their API keys in somebody's project, they will immediately terminate that API key. And so a lot of people in the developer forums for, say, OpenAI, the ones that I have listed here, will be wondering why their API key got disconnected, shut down, why their user account got locked, and it's because they uploaded this to GitHub. I'm missing the links right here to some security incidents related to people uploading API keys, but it's a pretty regular event. Like, let's say once a week on the security lists that I follow, a company has lost a couple $1 million because somebody uploaded an API key somewhere and a hacker found it and used their bank account to mine Bitcoin or something for a while until they got shut down. So this is a long way of saying that we should not do this. It works, but we should not do this. So what should we do instead? And the answer is inside of the documentation over here, but it's contained in a very roundabout way that if you're not used to reading documentation, you might miss, you might not see. It says down here that while you can provide an API key keyword argument, we recommend using the python.env program to add this to your .env file. so that your API key is not stored in source control. So that's a long way of saying so that other people can't steal your API keys. If you click this link right here, python-.env, you'll be taken to this pypi.org website. This website is pronounced pypi, P-Y-P-I, stands for the I forget what it stands for. Something like, well, every Python project that you install with pip is loaded up on pypi.org right here. And so if you ever see a link to one of these projects that you're expected to use, then it'll have another one of these pip install commands down right here. So this is what we're going to run to install this python-.env library. And that will give us access to this library, which will help us secure our API keys. So just copy this command right here, come back over to my terminal, pip3 install python-.env like this, hit enter, and it should all install fine for us. Back over here, scrolling down here to find some actual code of how to use it. It's a really easy library to use. All you have to do is add these two lines to the top of your program from .env import load.env, and then this load.env function right here, load.env. Copy and paste these two lines to the top of my project right here. I like to remove white space, keep things a little bit closer to each other. So I will put those together like that and save this. Now what is this load.env function doing? It's opening up this .env file and then putting all of these variables that are created in this .env file into a special location in Python called the environment variable list. And if we come back over to the original grok-python repository, we can see their recommended way of getting access to these API keys was this line right here. And so if I copy that line and now paste that line here, and I will comment out this line right here, save that. The API key that we are getting comes from this os.environment.get grok API keys, and this load.env is taking all the contents of this .env file and putting them in a spot where this function will be able to have access to it. And so now this should, if I don't have any typos or anything anywhere, this should also get access to my files in a way where I am not going to have a password directly hard-coded in my code anywhere. So I delete that, save this, up here, triangle button, and no error message like this, no error message. Maybe it's worth also seeing what happens if what would an error message look like? So if my API key here was empty for a second and we press the triangle button to run that, we get this error message, an API connection error, not super helpful, not super informative, but this tells us that the API key here is incorrect. But if I redo that, rerun it, then everything is correct. One last step that we have to do in order to protect our credentials right here is we have to, so now our Python file is totally safe. We can upload our Python file to GitHub and nobody will be able to figure out what our password is. But our .env file up here, if we upload this to GitHub, then people will still be able to find our passwords. And we've conveniently also put them all into one location right here that is a standard spot .env. If ever I see a GitHub folder with a .env file inside of it, the first thing I do is click on that to see if I can find anybody's passwords all the time. And then I troll them mercilessly with whatever, depending on what the system is that I have their password for. But in order to make sure that this .env file does not get uploaded to GitHub, there's one more file that we'll create here called .gitignore. Again, it starts with a dot over here because it's like one of these sort of hidden files that you're not really supposed to think about after you set it up. And .gitignore specifies what files should not be stored in your Git repository. And there are many types of files that we might want to include in here, but the most important ones, and the one that, the most important one is this credential file, this .env file that contains our password. And now if we save this here, save this .env right here, then when you go through all your steps to upload this project onto GitHub, as you're submitting this project, your .env file right here will not be uploaded. And that means that I will not know what your password is, and I will not troll you mercilessly. Any questions about the purpose of anything that we've done so far or getting things to work? Everyone's out of state where if you press the triangle button, things run. Okay. Then, yeah, we've done, again, all the hard parts, all the new stuff, and we are just ready to start thinking about Python and getting our Python organized in a way to pass interesting information off to the LLM and then use Python to extract interesting results from the LLM down here. And we don't even have to think about the details about what all is going on in this API. Why is it something crazy like this? I don't know why they chose to make it a very long way to pass something to the LLM, but that's what they chose. And we don't need to care or understand the details. We just know that if we run this, then we get access to the LLM. Okay, so that is coming back over to our topic 10 over here. That's all this information in this get basic example working part down here. Almost all of it. We haven't talked about this middle part right here. One of the confusing things about using projects like Grok that are very famous, that have many users in different languages, is that it can be hard to navigate the documentation to figure out what documentation is appropriate for your project. And here, one of the places that you might think about going to on a project like this is actually looking at the documentation in the Grok website. And it turns out the documentation in the Grok website is useful and interesting to somebody like me, but not at all helpful for the stuff in this class. This, under the hood, what this function call does right here is it uses the requests library to download something from the internet, and that something is the actual contents down here. And the documentation for that's on the main website right here. Anytime you see documentation for an API, they're talking about like the documentation for that web interface. And we don't care about that web interface. We just care about the Python interface down here. So it's very common, again, for these API-based companies to have a web explanation on their main project company websites, and then have GitHub projects in different languages that have the actual code that as a user you're probably most interested in looking for. So they have this grok-python right here. That's what we're using because we're using Python, but they also have grok-r or grok-matlab or grok-c++, grok-java, different APIs for those other languages. And there are the purpose of this web documentation is for people who are building their own libraries from scratch, not for actually using the libraries. Okay, so that's everything from the get a basic example working down to step 2, creating the actual document summarizer. So doing the interesting Python parts now. And our goal here, we're creating this docsum.py file that will take a file of any type in as a command line argument and then summarize that file using the Grok API. And so we've seen a little bit now about how to take stuff in as command line arguments. I actually always forget about how to do that, and I have to look up in the documentation here every time. So I have a link to the documentation right there, and it's these lines right here. So I'm going to copy and paste. What I've done here is under step 2, I just clicked the link to the argparse library down here, and that takes me to the Python documentation for argparse. and I'm going to be copying basically these sections of code into into VS Code here. So starting with this parser equals part right here, Control C, take myself over to Python, over to VS Code, and the standard place to put whatever you're doing with argparse is the very top of your project. Import argparse like this. These, this information here is something that's optional, but I'll go ahead and put it in. My program name is called docsum. A description of what I want it to do. It's going to summarize the input document, and then this is text that appears at the bottom of a help message. We don't need that, so I'll just use these two lines like this. I don't think I've done this yet in class where we have arguments to a function call that are, well, there's two things new here. The first is these are named arguments. So it's common in Python to actually specify the name of the argument before passing it in. You don't have to do that. We could just delete this and it would be the same, but it's a little bit less easy to read. So this is common. Another thing that's common in Python is to, if you have a lot of arguments that you're passing to a function, indent them and put them on a separate line so it's easier to read. And here it's from copying and pasting, it's a little bit too indented. So I'll select both of these lines and press Shift Tab to indent them back to what looks like a nicer level to me. I also like to have, when I have these big long lists like this, the parenthesis on its own line and each of these lines with a comma after it. That's just my preferred style of formatting. So this is creating that parser variable. And then back over here to the documentation down here, we have to add these arguments. The argument is, again, something that you pass into the program on the command line. And I just want to create one argument right here that file name is actually a good name for my argument. File name's a good name for my argument because I want to be able to pass in the name of a file to my document summarizer right here. So we'll save this right here. And then the way that we will get access to this information is, again, this args equals parser.parseArgs right here. Copy and paste that. And then let's do a print file name equals comma args dot file name like this. Save that. Often while I am working on projects, I'll have one part of the code that I care about and another part of the code that I don't care about. I don't really want to run the other part of the code. And in this case, we've been working on this argparse section of the code, and I'm not working on the sort of the LLM interface section of the code. And I just want to test up to line 9, not test stuff after line 9. So I commonly just add some gibberish right here to trigger a name error in Python so that only the top part of this code will run. And so I've done a lot of changes here, actually more than I'm comfortable with without having ran this. And so let's go ahead and run that. And this actually looks good to me. This is the expected output if you press the triangle button at this point and run your program. Here, when we have this parser.ag argument file name, this means that Python wants us to pass in some sort of file name on the command line to the program that we're running. And when we don't do that, the triangle button does not do that. We get an error from Python like this. I'll press the up arrow space. We'll actually add a file name now, and I'll just say hello right here. It doesn't have to be a valid file name at this point because I'm not doing anything with it other than printing it out. And so we do hello like this, hit enter, and we can see that file name equals hello right here is being printed because of line 9 right here. So I do have access to this variable now from within Python, and this ASD just to trigger the name error, seeing the name error down here so that we don't go on to run the LLM code. So my idea is, again, where I'm building up to is I'm going to be loading in a file and then somehow passing that file down, doing something clever with it in this code down here to cause the LLM to summarize that file for me. Any questions about this? This is all sort of review from stuff that we've done before. Okay. Me too. I'll just step back and make a meta comment of this. The main way for where you all are at as in your programming level experience, the main way to level up, the main way to get better at programming for you all is two things. One is to just actually do a lot of coding. So that's why all of our assignments are coding in this class. But two, to like sit down and observe how somebody more experienced than you does coding, implements a certain project. And so even though this sort of section of the class right here, there's not like, I don't know, one key thing that you have to learn in order to get a better grade on a quiz later on. This type of live coding in this class, I think, is the place where you'll get the most benefit out of the class, being able to observe the way that I approach problems and trying to imitate that in your own projects. I'll say that this semester, this happens every semester, but this semester there have been two seniors from Mud and Pomona who have come to me and asked me to for help with doing something like this on LLMs, where they had been working, they told me like 10 or 20 hours trying to get something to work. That's basically what we're doing right now. And I sat down with them side by side. In 15 minutes, we had what they were trying to do all totally implemented and working. And so this idea of like, yeah, live coding with somebody else, I think is the really, from my perspective, the most important part of our semester here. And we're now finally at the place where we can do a lot of that. And so I'm happy. Okay, let's keep going now. Do some more technical stuff here. Line 9, we were actually able to print out our file name now. What we need to do next is actually extract the contents of this file. And we've seen how to do that with the open command with open args.filename like this. And we need to open it for reading and with open as fin like this. Some people do as f. I like to do fin or f out to remind myself whether this file is for reading or for writing. In this case, it is for reading, for input, so I call it fin. And then I create my variable. We'll call it just text. Text equals fin.read like this. You'll commonly hear programmers pronounce variables as either fin or fin. I use usually fin when I'm explaining it because the F stands for file, in stands for input. So fin makes sense semantically, but I like to be as efficient as possible. And so in my head, I always say fin when I'm just thinking to myself. And so you'll hear me say both fin and fin, depending on which mode my brain is in. And now we have access to the text of this file. Let's go ahead and double check that this text contents is correct. Print text equals comma text. Again, whenever I'm working on a project, I've written 3 whole lines of code right here. I never move on to assuming that some portion of code that I've written is correct until I have verified this. So even though this is a small segment of code, I'm going to verify that it is correct. And we'll again press the come down here to do the up arrow to get back to my previous command. Here, if I hit enter and run this, we'll see we get this file not found error because I passed in the name hello, which doesn't actually exist in this file up here. So instead of using hello, I need to get a new file to an actual interesting file to pass into this system. Coming back to GitHub for a second, I have a couple of interesting files that we will work with in this docs. Let's refresh that. In this docs folder right here, I have these interesting files. We'll see how to work with all of these here in a little bit. But this declaration right here is the Declaration of Independence for the US. And this is the one that I want to start with. So our goal here is going to be to summarize the Declaration of Independence with an LLM. I'll have to get this into my project in any way that we have seen how to do this. The way that I will choose right now is press this raw button over here, Control A, Control C to get this entire document. Come over to VS Code, and I'll be a little bit more organized. Put a docs folder right here, and then put that file inside the docs folder, declaration like this, and then inside there, Control V, Control S to save that. So now all I've done is created this docs folder with a file inside of it, declaration, that has the Declaration of Independence. And our goal, again, will be to summarize the Declaration of Independence. Why does it say tech over here?
Like, how do you get it?
I don't know. So it's actually VS Code making a mistake right here. Tech is a programming language, and so it thinks that the Declaration of Independence, it thinks that Thomas Jefferson knew how to program on a computer. So that's just a mistake. Yeah, it's automatically determining what these symbols are based on the contents over here, and it's heuristics about what programming language that is. What tech actually is, it's if you've heard of LaTeX, it's a typesetting system. So it's like an alternative to Microsoft Word that mathematicians use a lot. And so it sort of makes sense to me that a bunch of text will appear as the tech programming language. And now coming back over here, I'll up arrow, change this hello to docs/declaration like this and hit enter. And it looks to me like it is in fact printing out the Declaration of Independence down here. So that all looks good to me so far. We are making progress. Okay, I will comment out these sort of debugging lines that I had before because I don't want to clutter up my input too much. So let's comment those out for now. And we're almost done here actually with the first step here of doing our summarization. We've got the LLM working. We've been able to load the information into the LLM, or sorry, load our document into Python. And now all we have to do is connect this text variable right here to our function call down here, which contacts the LLM. Any questions about where we're at before I do that? Okay. And the content right here, so the content, this is sometimes called the prompt. In the content is equal to the prompt. If you hear people talking about prompt engineering or writing good prompts for LLMs in Python, what they're doing is they're just changing the content of this content variable. And so here we just have to come up with a good prompt, a good set of instructions for the LLM to ask it what to do. And so what I've done so far is I've just deleted the contents of the string and I've added this F right here. The F again stands for the F string, which allows me to do the substitution of another variable into the string. And what I'm going to write right here is summarize the following document, colon, and then inside of this curly braces right here, again, Python in these F strings will do variable substitution inside of these curly braces. And so this will substitute the text of the Declaration of Independence here into the string. All of that will get sent over to the LLM. And if everything works correctly, we'll get a summary of the document out. Control S, save that, triangle button up here to run that. And the triangle button gives me again this error down here because I did not type in the actual file name. So I will press the up arrow to get back to the same command for running my docsum Python file space docs/declaration like this and hit enter. And here is my hopeful explanation of the Declaration of Independence right here. It's a little bit long, but it looks like it's actually talking about the Declaration of Independence, and this looks like reasonable sort of summaries so far. One last thing that we'll do today to improve this, but before we do that, any questions? Yes?
I think mine is just still coming out.
Still printing out just the declaration. The most likely cause of something like that. How do I get back to, there we go. If you're still just printing out the declaration, you probably still have print statements up here that didn't get commented out. So in particular, this one that I have on line 12, I commented that out so that I wouldn't see the actual text of the declaration. And then any like the ASD or something like that that caused it to crash, I made sure I removed those. And the function call down here, this big long incantation of a function call, the important change is changing this content right here so that we have some instruction right here about what we want the LLM to do, followed by substituting the text right here. And this last print statement, what this all, we'll go through the details of this next class, but what this is all doing is just extracting out the response of the LLM right here. And so hopefully all that together should.
It might have summarized it underneath the declaration. It might have been out declaration.
Okay, I got it.
Yeah.
Yeah, thank you. I think I just forgot to take out that, like, the breaking text.
Yep.
Thank you.
Okay. One last thing that we'll do for today is, again, this is like a big, long summary, and I don't know, it's not quite the same length as the declaration, but it is still annoyingly long. And so we'll do a little bit of starting with this prompt engineering, thinking about how do we get good results out of the LLMs. And a very standard thing, anytime I'm using an LLM, I always provide an instruction about how long the output should be. And so that's just like a prompt engineering 101 thing that you should do with LLMs. So summarizing the following document in one paragraph. And then I'll, in parentheses right here, say max 3 sentences. So this should actually be a very short summary of the LLM, or sorry, a short summary of the declaration provided by the LLM. And now press that triangle button. I keep doing this up arrow. I have to actually, again, specify this docs/declaration here so that it runs it. And now we get a reasonable short summary of this document. The Declaration of Independence, blah, blah, blah. That looks like what I want it to look like. Any questions about any of that?
Will you just go back to the code where you said
Yeah.
and here?
Yeah. So this is what my instruction looks like. I'll see if I can get it all to fit on the screen at once here. Next time, well, let's see. Next time we'll see how some failure modes of this code that we have here and how to fix those failure modes. So we're not done at all yet. We've done maybe 15% of what we're going to be doing with this. That we basically have like a good prototype. It, in some sense, looks like we're done. If you were showing this off to a non-technical boss, you could argue that you are done with it. But we'll see all the different edge cases that cause this to break and not do what it should do. Okay, if anybody does have more questions, I'll stick around and get those answered. Otherwise, that's it for today. And good luck. Well, yeah, no good luck. Well, yes, sure. Good luck on your project. So see you tomorrow in the lab.